Welcome to Modern Steel Construction's Field Notes podcast. I'm your host, Jeff Weisenberger. This month's guest is Kara Peterman, a structural engineering professor at the University of Massachusetts, Amherst. Welcome, Kara. Thanks for being here.
Hi, Jeff. How are you?
I am well. I always like to start from the beginning, and I know we'll talk a lot about stability research and that sort of thing, but first things first, where are you from? Where did you grow up?
I grew up in Hong Kong when it was still a British colony. And then after 5 years, my folks moved to Fairfax, Virginia, where I spent the vast majority of the rest of my childhood.
Wow, that's amazing. I didn't know that about Hong Kong. Do you have any memories of growing up there?
Even though I was very young, I turned 7 right after we moved to the U.S. I remember the food. I remember growing up on an island and taking the boat everywhere, and my friends. It was great.
That's excellent. Well, now that you bring that up, I have to ask, well, how were your parents associated with Hong Kong? What were they doing there?
Oh, it's so complicated, but essentially, my father was working for Apple Computer, Far East Asia.
Gotcha.
Which I think was what they called the branch back then. But my parents have a lot of history in Southeast Asia and both spoke Chinese very well. And so we have a long familial history with the region.
Excellent. Yeah, my parents actually met in a Chinese class in Ohio State University.
Oh my goodness, that's where my parents met. That's so funny.
Oh wow.
At Vanderbilt, not Ohio State.
Oh, okay, gotcha. No, yeah, sure. Have you been back since?
I have been back. Yep, and I remember a lot of things very clearly, which is pretty amazing.
Like getting a little bit more into your professional career. So, what got you interested in buildings in the first place? Were there certain buildings that you saw when you were younger that you thought, oh, wow, this is my inspiration to become an engineer?
I wish I could say that. You know, it would make a really nice story for me to say, oh, growing up in Hong Kong, I saw the Bank of China Tower. But alas, no. I went into college knowing that I wanted to be an engineer, but I had no idea what type of engineer. And so I kind of waffled around the various types. At my particular college, we get a general engineering degree, and then we have the choice to specialize starting in the junior year. And so I was all over the map. I was like nuclear engineering, electrical engineering. I was no idea. But then I took an art history class and saw a picture of a Gothic cathedral ceiling vault. And was just really amazed by how they managed to do that back in the 1200s and how that structure worked. You know, the focus began to sharpen on what I really wanted to do. And I dedicated myself to structures after that.
Oh, that's amazing. I love the irony of, starting to be curious about structural engineering based on an art class.
Mm-hmm. Yeah.
That's pretty cool. Where did you go to school?
I went to college at Swarthmore College, which is a small liberal, I can never say it, liberal arts college in Philadelphia.
I also wanted to get into your role with the Structural Stability Research Council, the SSRC. Can you talk a little bit about what you've been doing with that group and how you got involved in stability research?
Sure. So I'll start at the beginning. I got involved in stability research through my master's and my PhD work at Johns Hopkins. Okay. I did most of my studies in cold form steel, and cold form steel is a very, very slender and thin steel building material, is obviously susceptible to a lot of stability failure modes and that type of thing. So my first ever conference presentation or conference in general was NASCC, and I gave a talk at the SSRC sessions. And that was in, I think, 2010, maybe 2011. It's been a decade, I think. And so I started as a student member, and I was a member of a lot of task groups. And then after I had finished my PhD and was a postdoc at Northeastern, I was asked to take on the role of vice chair for the thin-walled structures task group of SSRC, and then quickly went on to become chair of that, which I recently finished my 2-year term of being chair of that task group, so 6 years. And then very happily, just recently, I was voted to be on the executive committee for SSRC. So it's a group that I always thought was really welcoming to me from the very beginning, you know, when I was a 22, 23-year-old researcher straight out of college, and has helped me advance in my own career.
What do you see as some of the next new topics when it comes to stability research?
Yeah, I think the types of problems that we apply stability solutions to will continue to broaden. I know there's a lot of exciting work in the energy industry where there's a structural stability solution or to make a more efficient wind turbine, for example. I think we'll continue to see development there. I think there's really quite a bit to be done in improving building information modeling, BIM modeling, with more stability information. I think advanced manufacturing techniques, additive manufacturing, 3D printing have a role to play. How does steel or other metals that is printed or formed behave differently from traditional steel? So that's where I'm thinking, but we'll see. The industry always has a way of innovating and surprising me.
For sure. No, but those sound like interesting topics. And yeah, the whole concept of 3D printing, especially. I mean, obviously we're just kind of at the tip of the iceberg on that right now when it comes to structural applications. Well, switching gears a little bit, let's talk a little bit about your career at UMass. Now, what made you decide to go into teaching in the first place?
I think for me, there's a lot of ways an engineer or a structural engineer can have impact in the world. And certainly designing a building that is used and loved and a central part of the community is a fantastic way to have impact. For me, being able to teach people what I do and sort of give back in that sense was very important. The research lens is obviously very important to me as well. Thinking about how I can take the tools that I learned in my studies and make the world a better place. I know that's a trite phrase. So it's just a way of how I prioritize making a mark on the world. My PhD advisor, Ben Schaefer, recently told me a quote, which I have been keeping in my mind, but he says, you're much more likely to teach a genius than to be one. And it really has made me think deeply about, I can say that I'm a capable structural engineer, but I'm much more likely to teach somebody over my career who's going to invent the society changing thing or the startup that turns into the big multinational company. And That's pretty exciting.
No, it is. And that what's kind of interesting about it too, I suppose, is the unpredictability, because who knows what amazing things are going to come out of, your teaching. And then like you said, you might, like a former student can do amazing things, or former students. And as far as making the world a better place, it's funny. It's like whether it's altruistically done or it's stated up front. I think it's one of those things at the end of everybody's lives. You look back and you go, God, I hope I did that in some way, even if it's just on a small scale.
I do think civil engineers get into civil engineering because it's a profession that serves the people, that on some base level appeals to all of us. When we think about what we need to survive, it always comes down to food, water, and shelter. And being that shelter part or working towards making sure that shelter part is available for everybody, I think keeps a lot of us, it helps us sleep well at night,
Absolutely. Well, so yeah, speaking of the teaching and research, can you just talk a little bit about like what classes are you teaching? Are we talking graduate level or undergraduate, a little bit of both?
Yeah, I teach both. So historically, I taught strength and materials, which is super fun, and advanced steel design, so our graduate level steel design course. And then did that run for a couple of years, and then recently switched over to teaching statics, which is also fun. And I developed a new course at UMass called Unified Structural Design, which is a structural systems class. So we look at arches, we look at repetitively framed buildings. We look at cable supported structures and then tall buildings. And we actually talk about the design of those systems. So that's a new course I developed, and I'm on my second year teaching it. And that's been, it's all been fun. So what else can I say?
Excellent. Well, and then switching over to research, are you able to talk about some of the current research you're involved in, or is it top secret?
Top secret would be pretty cool. I would make me feel a lot cooler than I normally feel. But yeah, absolutely. I'm doing a lot in floors and in floor diaphragms right now, and have a project where eventually, hopefully in the next year or so, we'll be doing some shake table tests of some cold form steel diaphragms, designated lateral force resisting systems for floors. And we're looking at a couple of new or proposed structural systems, what we're calling a dual skin system, which looks at, cold form steel joist with steel deck and then a fiber cement board or cementitious panel on top of that. And that's been pretty exciting, doing work towards developing something that could take off, or we hope it takes off. Looking at a lot of deck research, especially coming up this summer, steel deck. And then concluding a couple of shear wall projects where we were trying to do some high fidelity shear wall modeling. That work, I say it's nearing completion. Yeah, I've also spent some time doing thermal modeling work for cold form steel, which has been very interesting too. Trying to make our steel buildings, as sustainable as possible, and have a couple of collaborations with some architects at UMass trying to push that forward.
Sure, and I'm assuming that has one component of that is thermal bridging.
You bet. Yep.
Yeah. So you mentioned shake tables. I don't know where all of them are. I know there's one in California. Maybe it's in San Diego. What's the closest shake table to you?
Yeah, so the closest big one would probably be in Buffalo, but
Okay.
we're actually going to make it hard on ourselves and do it out in California, in San Diego.
Gotcha. Do you have, as a professor, for undergrad, graduate, and then, students that have recently graduated, do you have some general or even specific advice for engineering students going out into the world or that are just starting out?
I think there's a lot of pressure on young folks these days to have it all figured out as soon as possible. But I think, to me, that there's an important bit of perspective that needs to come into play, that life is long. And I think that bit of advice can be used at various points in your career. I think the pressure to have it, for a student to have it all figured out as a college freshman, it's very palpable. I see it in my students, and yet, they're 18 years old. How can you possibly have it figured out at 18? So I've always been advocate for, trying out different types of internships, taking a wide range of classes as much as you can fit in an engineering degree program throughout your career. Getting a PhD in something doesn't necessarily mean you're tying yourself to that topic throughout your whole life. A working person will expect to work between 30 and 40 years, and that's an awful long time to be doing one thing.
Absolutely.
I think it's great if it works out and you're in the thing that you want to be doing, you're very happy doing that thing. But yeah, life is long, and I don't think students should feel pressure to have it all figured out. And rounding the corner back to our original, we were talking about our parents. My dad's PhD is in Buddhism, and he's not a Buddhism scholar right now. I mean, he went to law school at age 45 and started off in an office where everyone else in his job title was in their mid-20s. And he was 2 decades older than them. And he's had a fantastic 25-year career as a lawyer. And at the time, I didn't think about how much courage it took to do that, to go to law school, quote unquote, so late in life. But I think about it a lot these days. And it's a story I tell a lot of people in my life, just because, it shows that you can do the PhD, you can have all the degrees, you can do all this stuff, but it's never too late to make a change.
Very good. So what do you like most about Amherst?
I think what I like the most is the self-sufficiency of the community. I think Western Mass in general, Amherst is just one town among many small towns. I happen to live one town over in Northampton, which is another great place to live.
Oh, that's Smith College, right?
Yep. I live right across from Smith. In any event, we have just a huge amount of local stuff. Local food, local manufacturing. That to me, it speaks to a larger sense of self-sufficiency than I've seen elsewhere. And, the fact that I could go and get all of my food for the week farmed within 50 miles of where I live. The quaintness of New England is not something I've ever gotten used to. It still strikes me as being really beautiful and really charming and really quaint. Coming from, I was a Virginian for so many years, a very new part of Virginia where we have no old buildings, no old churches, nothing. And the building I'm living in is 100 years old. And so many of our churches around the area are hundreds of years old. And that the general age of the area is something that I'm just not used to yet. Yeah, I notice it all the time.
All right. So now I want to hear about the clarinet. You play the clarinet. What's your history with the clarinet? How did this all get started?
Yeah, so I do play the clarinet. I have been playing since I was 10. I'm 33, so that's 23 years. At this point, it's interesting to me because I'm an engineering professor. That shows that I know things about engineering, but I've been playing the clarinet for way longer. When I think about my identity, I identify, I think about myself as an engineer. I think about myself as a musician, but I've been thinking about myself as a musician for way longer.
Sure.
So in any event, those things that's always been interesting for me. I play in a wind ensemble called the Valley Winds here.
Okay.
And I also play in a symphony orchestra, the Pioneer Valley Symphony Orchestra. It's just something I love to do. I've always been completely addicted to playing with other people and have never found a reason to stop. No matter how busy life got, I always prioritized it, and gonna keep going.
Oh, that's excellent. Well, it's something that you can always kind of, no matter what else is going on, you have that.
Yep. Yep. That's
So
right.
what's it been like now? I'm just curious, like, during COVID, like what's that been like? Is it, have you been able to meet in person, or is it a lot of kind of like online remote performances?
Yep, you got it. Have not been able to meet in person with anybody, which has been pretty sad because the communal part of music is probably what I like the most. I mean, I practice alone. I've always, practiced by myself, but the actual getting together with people to do that together has been the real joy of it. But both of my groups have done some form of video Zoom concerts where we record by ourselves to what's called a click track, and then an audio engineer or somebody who knows what they're doing syncs them all up, and we have a video. It's pretty amazing to me how good they can be. The first time I did one, I was like pretty blown out of the water, but it's recording a take over and over again to try and get the best one alone in your room is not the same experience as playing in an orchestra with 60 other people.
So I understand you gave an NASC session earlier this week, and I think you also mentioned to me that some students were involved in sessions too.
Mm-hmm.
Can you just give me a quick update or a quick description of those?
I was fortunate to win an award this year. I won the SRC McGuire Award for Junior Researchers.
You did. Congratulations.
Yeah. Thank you. And part of that was you get to give a talk on your recent work. And so I spoke on Monday about that and highlighted a project of mine, a former student of mine did that had more interesting stability component that we had more or less figured out. And that was fun. And then my two of my students, Fanny and Hernan, they presented, Fanny actually presented on some plate lattice metamaterial work. So a completely different direction from cold form steel, but a very fun collaboration with a colleague of mine. And then my student Hernan presented on diaphragm work. So he's been doing the bulk of our floor system work, and he gave a great presentation on that.
If I or anybody listening here were to go to Hong Kong, I'm not going to ask for a restaurant recommendation necessarily because things always open and close, but is there a food that you need to try there, a specific dish that they're, either you can't get anywhere else or they do it better than anybody else?
Dim sum. Dim sum is a style of eating more. I mean, there are dishes that are common to dim sum, but dim sum is a style of eating, usually like weekend brunch type format. And I said there are dishes that I usually don't find elsewhere except for dim sum, but for the most part, going to have a proper dim sum brunch, just an experience everyone should have in life.
Okay, excellent. And is there something like maybe like one particular place or monument or building or some sort of icon that everybody should see when they're there?
A structural engineer should certainly see the Bank of China Tower, I think. But
beyond the structural bracing on the outside, the X.
Yep, that's the one. But beyond that, the Star Ferry is this ferry that's been in continuous operation since the mid 1800s. And it goes from one side of the Hong Kong harbor to the other side. So it goes from Hong Kong side to Kowloon side. And a token to get yourself across is, I forget how much, but like 20 cents or something. And you ride the boat across and you get one of the most spectacular views of Hong Kong that's available. In addition to riding this ferry, that's this old style, low-tech ferry across the harbor. And that's just one of the best ways you can spend an hour, just ride back and forth.
Very cool. No, whenever I get to Hong Kong, I'm going to do both. I'm going to do the ferry. I'm going to see the buildings, and I'm going to eat some dim sum.
Eat some dim sum. That's right.